Hello viewers, welcome back to my channel. This is John from Cloud Tech Insights. In today's session, we'll be talking about the generative AI journey for emerging organization. Let me explain what an emerging organization means. So an organization who has not played with AI models or a traditional models or does not have an advanced MLOps team, just taking baby steps towards AI. That is where we are focusing in this session. And I'll be providing the different steps, how you can implement generative AI in a layered fashion. This will also provide you an iterative or an agile fashion to give your C-levels or the project sponsors some quick wins to show some confidence on the project and then move on with the bigger steps. So we are following a design principle called KISS, which is the keep it simple and stupid. We are making sure that you have less heavy lifting on the ML team side and making sure that you can quickly implement less overhead management. That's the focus of today's roadmap for emerging organizations in AI. Before we move on to the session, I want to quickly announce that I've released a course called Amazon Bedrock Learning Series on udemy.com, leaving the link in the description. This course is especially good for organizations who are emerging and into the AI space. Definitely good for beginners and intermediate folks who wants to learn and get into the AI space. Please support me by subscribing to the course. I've left a coupon in the description below. So let's begin with the roadmap, and this is the high level 11 steps that I would recommend for any organization emerging with AI use cases. First step for the emerging organization or in general is to have a clear use case. Use case formation is the first step. Ensure that you define your business problem and objectives, and the most important part is it should align with your organizational goals, demonstrating value propositions. So this is very important. Take the time, define your use case, and in that way you'll be able to clearly design the framework around Gen AI to support your use cases. Next comes the data discovery. This is the most important part. You want to make sure before any Gen AI initiative that you have the data to support the Gen AI use case, all the informations, especially when you try to implement the RAG methodology where you are asking the LLM to explore your data sets and come back with an answer to the end user. So you want to make sure, hey, you have the data set. How often do you want to refresh those data sets? How often do you want to keep it updated? Does it make sense to keep it updated in real time or in batch? Because based on your use case or the business requirements, sometimes it may be a batch requirement should be good enough. Some cases, real time should be good enough. Or some cases, you want to make sure that you have the data set in a queryable format. So you want to make sure that you do the data discovery before your Gen AI initiative so that you can design your RAG methodology, the RAG process flow, or the workflow for your Gen AI or the LLM. The next comes the model selection. So this is where we got to keep in mind whether you are going for a Bedrock style approach, then you want to stick to the proprietary models. And for emerging organization, I would always recommend to stick to a proprietary model because it has been tested thoroughly by the vendors, and you have the connection with the vendors in case if you want to have certain questions asked, and you'll get a lot of support from some of these vendors. So that's where emerging organizations should just focus on proprietary models to begin with, and later on in the game, once you get the quick wins, you can think about moving on to something very much open source, and we can get into the other complexities of the LLM. And this is the most important part: is look at the leaderboard and see if you have some models or proprietary models that aligns with your business use case. And I always tell people that you don't need the big and a complex model to make simple decisions, right? Some decisions can be just made by a simple model, right? So make sure that you don't use a heavy model and end up spending a lot of your budget on some of these model hosting and inference, etc. So start with the smallest model, and then you can see if it's solving the problem. And if it's not exactly solving the problem, the next step is around prompt engineering. And this is very powerful. We can also call it as prompt engineering or prompt tuning. This is important part. Let's say if you pick a small model and it's not providing the expected results, then you should think about prompt engineering, making sure that you tell the model how you want the output to be, what level of thinking. Do you need chain of thought or a single prompt? These are the things that you can instruct the model. Sometimes the prompt can also be enhanced with a lot of context. So the RAG also provides some context. The RAG searches certain keywords and sentences and provides that as a context for the prompt so that it can answer your question based on the information it is provided. In addition to RAG, if you can provide some context and the expected outcome from the results, or like a role playing where say, hey, you are like a software tester and you have to look into this particular SQL, run the SQL against the database and check if it is working right or wrong. So you can also do advanced level of prompting to get even the small model to answer majority of your queries. In this way, you're keeping the inference cost very low compared to hosting a huge model on a bigger servers and costing higher for input tokens and the output tokens. The next comes the model evaluation, and this is the most important part. People tend to skip this part. If you're an emerging organization, you may not be familiar with the typical workflow or the process flow within traditional ML, where you start with data prep, training the model, hosting the model, serving the model, evaluating the model, testing the model, and then performance testing the model. So with the LLMs, you are skipping basically the data prep and the training part and jump straight into the hosting the model. And some people tend to forget about evaluation. And this is the most important part. Even if the model is trained or is just a proprietary model, you want to make sure that you evaluate based on your specific use case. There are two options. One is you can get the data sets from the open source, from GitHubs, and then evaluate the model against it. But if you want to be evaluating the model for very specific use case, you should start creating your own data sets, and you should run the evaluation probably one, two, or three times sometimes, because the evaluation is different from the traditional models, where the LLM model can provide different responses once you ask for the first time, second time, and third time can also vary based on the LLM model. So this is very important to keep in mind. Make sure that you evaluate your model with the pre-built data sets or your own data sets, and ensure that you put guardrails. Guardrails are like a leash on the model. You want to keep it on the tight leash. You want to make sure there is no biases, there is no abusive language, and the most important part is the prompt injection. So you want to make sure that the end user or any bad actors can prompt the model to provide the data structure and the sensitive data which resides in your RAG methodology. So make sure that you go through some of those guardrails, setting up those guardrails. And I've seen Bedrock make some of these process seamless. You can quickly add the guardrails. You can evaluate the model based on the pre-built data set, or you can bring your own data set. So some of these models, Bedrock makes it much easier. And the next comes the model testing. So this is different from evaluation. Evaluation testing might sound very similar, but testing is something that you're testing the model with the data sets that happens in real life use cases. Ensure that it's doing well with the unseen inputs, and also play with the prompt engineering, prompt injection scenarios to make sure nobody can access the data behind the LLM model, And you can always use human testing, end user testing, or also automated testing to test these models for different scenarios. And like I said, each time when you ask a model or test a model, you get different response. Then that's the difference between the traditional ML versus the LLM style approach. And then comes the feedback. So it can be an internal team, or it can be an external team or end user who can immediately provide a feedback. Some organization I've seen, they provide a beta version to the end users to like test out the model and see what improvements or what feedbacks they can provide. And based on these feedback, you can quickly switch to another model or engineer the model, etc. So this quick feedback loop is extremely important to understand how effective is your model. So overall, this is an iterative process. So based on the feedback, you can pick and choose a different model or keep the same model, then go through the prompt engineering and then go to the evaluation and testing. This is like a flywheel approach that enables an agile fashion and helps you build confidence in your whole process. So that's where this steps really help for emerging AI organization to give the C-levels or the executives a quick win and show confidence in the approach that we are following. And next comes the model serving. So once you've decided the model, tuned the model, everything's looking good, that's when you start serving the model. Model serving is basically just hosting the model on the inference chip or a processor. And this is where you don't, in Amazon Bedrock, everything is taken care of behind the scene. You don't have to worry about how to choose the instance and or availability of the instance. And if you are especially in on-demand fashion, Amazon Bedrock really plays good and reduce the heavy lifting on your organization. And once you start serving the model, you want to make sure that you can performance test. So this is a real life use case. So based on your usage style, some people might have a spiky usage. Some people might have like a consistent usage. You want to make sure that you test for the worst case scenario here. Try the different traffic volume and see the performance. If the performance is not up to the standard, you can always purchase a performance through the Amazon Bedrock option. So you can get a certain performance. You can pay for the certain instances that's up running behind the scene to handle the inference request from your end users. Up running behind the scene to handle the inference request from your end users. And then comes the model deployment. So once the model is ready to go, you can deploy the model, and there are various ways that you can deploy the model. You can deploy a beta version, get a feedback, or you can just deploy the model in A and B fashion, where you can test both the models, different versions of the model, different prompt tuning. So here in traditional ML, there used to be two different models when you train with two separate data. But in LLM, it's more of the prompt engineering. You can try different prompts, context, and RAG to see what best performs. Again, Amazon Bedrock makes it much easier. You can quickly deploy the model, etc. And then comes the end user feedback. Again, this is very important to have a beta version opened up to your end users, and they can play with it and provide a feedback on the responses, and then make sure that this feedback goes for a couple of months before you deploy it as a full production ready model, because you want to make sure you're providing the same experience as a human for your end users. So take your time, understand the feedbacks, respond to your feedbacks. You can go back to the main level where you can start from the model selection, prompt engineering, and go different cycles. So it's an iterative process, but this roadmap provides you a quick wins along the way, improves confidence in your C-levels, higher up managements, and they see a progress in iterative fashion, and also helps you capture the feedback and goes through the loop until the model is ready for the end users. So like I said, this approach is mainly for the emerging AI organization, not for somebody who is advanced in ML ops. There are like more steps that we can include, but this is a very good start. You can start from here and then ensure that you see those wins, and this will also build up confidence within your team and start building those skill set amongst your team, the culture around ML ops. So in that way, you can build the team as well as implement some of those use cases in the production environment. With that said, wrapping up the session, in the next few videos, I'll be focusing on mid-level and mature ML team roadmaps. And in this, to conclude, I want to say for any emerging AI organization, stick to Amazon Bedrock, where you can use the proprietary models and some of the ML ops is taken care behind the scenes for you, reducing the heavy lifting, also reducing the risk of project failures. So quick wins are very important. It layers the confidence within the organization, and it's a good start for building the AI culture, the organization. And once you are there in the mid-level or a mature level, I'll be creating some of those videos for organization which are like halfway through or like full-blown ML ops team, and wait for those videos. Thank you again. If you like the video, hit the like button and subscribe to the channel for the latest information. Signing off, John.